4 years old.
Apologize for Jessalyn, I'm one of the librarians here, and we're delighted to have Abby Ross from the math department here for our first Scholar Series of the year. Abby is in her second year teaching math at NMH. She received her degree in math and French from St. Lawrence University, as well as a master's in data science and complex systems from the University of Vermont. Please join me in welcoming Abby.
Studied French?
I studied French, yeah. Believe it or not. Thank you so much for coming. This is a really fun project for me to talk about, although it can get a little heavy at times. I think just looking at the title, you can kind of see that. We're going to be talking about ways to quantify gendered and biased language, looking specifically at media coverage from the 2016 presidential election. Just right off the bat, it sounds really political, but it's not. I'm going to try to leave all of that outside and just talk about the math, just the math that we did, the results that we saw in a totally apolitical way. If you have questions throughout, just raise your hand. That's fine. Cool. And this is research I did at the University of Vermont with the Vermont Complex Systems Center and my research group, the Computational Story Lab, funded by CA Technologies. Great. So I was in grad school during the 2016 presidential election and all of the run-up to it. And I kept seeing things on TV that were really frustrating me and being like, oh, that's so, like every day it was just, and more, but I didn't know if I was being hypersensitive, a little bit of like, oh, people are saying really mean things about women all the time. People are saying really mean things about people of color all the time. And I didn't know if I was just being hypersensitive or if there was really something there. And I figured there really was something there. But there wasn't really a way for me to figure out what. So that's kind of the goal of this. But I was seeing things like this. I was seeing, Clinton needs a shock collar so the aides can sack her when she starts getting screechy. Or even things not related to the election, like Michael Phelps tying for silver being the headline, and Katie Ledecky setting a world record being like much smaller font. These sorts of things. Or Serena Williams to play against this woman in Battle of the Moms. You never see Battle of the Dads. You don't even know which famous athletes are dads, but it seems to be such a thing when it's a mom. And so just taking all of these into consideration, I went to my advisor and was like, I feel like there's something, but I don't know how to say, this article is 4 more biases than this other article, right? Like it feels bad when you read it and it feels like unequal, but there was no way to quantify that. And so that was kind of my goal going into this. And I wanted to, I figured that the language used to describe people in media coverage displayed unconscious biases, gender, race, all sorts of different biases, and I wanted to not only identify it, because that's kind of the easy part, but quantify it in a way that made sense mathematically, as well as a way that we could kind of walk away, if you have no math background at all, and be like, wow, this is actually something that makes a lot of sense. And so I went to my advisor and I said all of this, and he had this amazing data set, which is given to me from Adrienne LaFrance, who writes for The Atlantic. And it was about 80,000 newspaper articles that were all about Hillary Clinton, Donald Trump, or Bernie Sanders from a full year before the election, or like 13 months. And all of these articles are tagged as this article is about Donald Trump, this article is about Hillary Clinton, or the same article could be about multiple different people. So I had a corpus for Clinton and a corpus for Trump and a corpus for Bernie. And then I also had newspaper articles about Bill Clinton from the first time he ran for president to kind of just get a historical perspective, see if things had changed in the way that we were talking about people running for office in that amount of time. So that was used as a comparison. So all in all, about 100,000 newspaper articles. The newspaper articles came from print newspapers, the most popular in every state in the country, and also the really popular ones like New York Times, Washington Post, all their online stuff as well. And it was every single newspaper article in that 13-month span that mentioned any of them or about the presidential election at all. So really huge data set, geographically diverse because it's from across the whole country. But also, it's important to keep in mind that this isn't like Breitbart. This isn't like InfoWars. This is like the Greenfield Recorder. Is that the one? Right. It's not the Greenfield Recorder because that's not the most popular in the state of Massachusetts. But it's print newspapers, just normal, everyday newspapers, which is important to keep in mind as we see some of the results. And the hard part then was I had this data set. I had a giant JSON file that could like barely fit on my computer, and all of the data is words. And as a data scientist, you're really comfortable playing with numbers, and as a mathematician, you can do a lot of number stuff, but the data was words, and that makes it really, really hard. So I just started asking it questions. I wanted to investigate my hypothesis, and I had this really cool data set, and I wanted to just figure out like, what can I learn? How can I try to study this using all of these articles that I have? And I have some computer science background, so I could write some programs and have my computer do all the hard work for me, really. And it came down to a bunch of different methods that when they come together, seem to paint a pretty nice picture. It's not nice, a whole picture of what was happening during this time. The methods that I used to investigate the hypothesis kind of broke down into two categories. There was the poke and prod method of like, here's all these articles. Ooh, what happens if I look at this? What happens if I ask about this? What happens about this? Which really depend on what you ask it to get the results that you're interested in. And then a couple methods that are more, what's the big picture? Mathematically, you don't really have to ask it a specific question. You can just kind of get painted the whole picture by doing some really cool and incredible math stuff that I won't get into the hard math of it. But I looked at these two different methods as a way for me to say, okay, I have questions about this. I'm going to do these things to try to answer my questions, and then I'm going to do this to see if I'm missing anything, to back up and be like, what's actually here? Cool, and the results that I'll talk about are mostly about gender bias, but I replicated all of these tests for all different types of bias, and we can talk about that at the end if there's time, or just if you have questions about those as well. So I'm going to go through a few of these different methods. I started out, you get a giant JSON file, 100,000 newspaper articles, and I just started counting things, just to see like, how many, like what are the words that are being said here? And I was looking at gender marking terms, so he and she and woman and man, that sort of thing, to just see who are we talking about in these articles. And so the first question I asked is, is he being said and she being said, and how frequently? So here, these are the different corpuses. All the articles about Hillary Clinton are here, and 0.1% of those words in those articles are the word he, and a just slightly smaller amount is the word she. So that's how you can read this. You could notice that in articles about Donald Trump, we're talking a lot about a he and very infrequently about a she. And I mean, during this time, Donald Trump is running head-to-head against Hillary Clinton, but so is Bernie Sanders. And we're talking about a she a lot more often in articles about Bernie than in articles about Trump. Which I think if you read articles during this time at all, you might have noticed articles about Trump tend to be a lot about him because of whatever he has done or whatever he has said, and articles about Bernie often showed both sides, at least in what I was reading. So I wanted to kind of see if that was really what was happening. An interesting thing here is that in articles about Hillary Clinton, we're saying more he than she. But I think that makes sense because there are so many more he's in the political world than there are she's. So maybe these articles aren't all about her. They might not be all about Donald Trump, but we're not really sure. So I figured counting was a great place to start, as well as counting the presence of different gender marking terms like man, man, woman, and women in each. And now this is just looking at articles about Donald Trump and articles about Hillary Clinton. Hillary Clinton is here. So the word man makes up 0.005% of all the words in articles about Hillary Clinton, and almost double that for the word man in articles about Donald Trump. So man is being said a lot in articles about Donald Trump. Men, not very much. Woman, not very much, although articles about Hillary Clinton, it makes sense. There's a lot of, the first woman could be the first woman to become president, that sort of thing. And a really surprising number of plural women, which was shocking in both in both data sets. Both types of articles were talking a lot about plural women, which was really surprising to me. And so I wanted to kind of dive into that, be like, what in the world are people talking about when they're talking about all these women all the time? Because that wasn't really what I was seeing as like a news consumer. And so I wanted to investigate that a little more. And the way I did that was by calculating an odds ratio, which is basically just a measure of association. It's like a ratio divided by another ratio. And this is basically the math, but it just involves counting and dividing. It's not anything crazy. But I'll look at this example to walk through how I did this. So in all of these articles, I looked for the word, for example, woman. And then I took the 5 words before and after, figuring that around the word woman, in those words you would see what people were talking about. I think that, like, roughly around there. A couple things that didn't take into account periods or quotes or anything. So if it was within 5 words, it was counted, even if it was part of another sentence. Even if woman was the last word of a sentence and this was part of a new sentence, those words still counted. So I called that the search term neighborhood. So that's the neighborhood of the word woman, was the 5 words before and after. And within those 5 words, so I collected all of those words for every single time woman was said in every single article about Hillary Clinton or Donald Trump. This is an example about Hillary Clinton. So I collected all of those 5 words before and after, and I kind of put them into a bag. And I said, all right, these are the words that are said near the word woman. How many times, so here's an example for the word becoming. Becoming is said 97 times within 5 words of woman in articles about Clinton. And there are a total of 47,000 words around woman in all of these articles. So it makes up 97 out of 47,000 words that are near the word woman. And then I divided that by the number of times becoming is said total in all of the articles, and divided it by the total number of words in all of the articles. So kind of just a ratio, how frequently is it said close to the word woman divided by how frequently is it said at all. And the resulting number that you get, which is the exciting part to interpret, is that this means 26.93. So if the word becoming is said, it's 27 times more likely to be said around the word woman than anywhere else. So you see, I mean, becoming is a kind of nothing, not very interesting word. Really, it doesn't say much, but it was said around the word woman a lot. And if it was said, it was 27 times more likely it was said around woman than anywhere else. So that's kind of the interpretation that we can go with. And so I did this with Python. All of this is in Python, and I have actually all of the code here. It's not anything crazy. Long. Okay. That sounds bad. It's really like this, and that's it. So this little block of code takes all of the word men, or we can look at this one. Looks at the word men, and then it just collects the 5 words before and after the word men, puts them off to the side, and then these 4 lines of code just spit out the words that are said more there than anywhere else. So if you know a little Python, it's a really, really powerful tool. You could ask those of you in my Python class right now. Okay. So I wrote some code, and I threw my data in, and it spits out all these words with all of their associated odds ratios, or the frequency of them being said. So the way we can interpret this is these are words near the word women in articles about Hillary Clinton, and unmarried is the most likely word to be said near women than any other word. And if unmarried is said, it's 80 times more likely it was said near the word women than anywhere else in these articles. Does that make sense? So we can read these words. This is articles about Hillary Clinton, and over here is articles about Donald Trump, when you look at words to describe women, or words that were used around women that weren't used other places as frequently. A warning that there might be some inappropriate language here. It's someone said it. And it was also, these are words that were said more than 50 times in articles. So if it was said a couple times, I threw it out. It had to be said more than 50 times in all of these articles put together. Some things I noticed that I guess were interesting are these words aren't great, but these words are worse. They feel worse, I think, as a reader. And if you read news coverage during this time, you probably this kind of makes sense. So this is words near women and articles about Clinton and Trump. And this is the kind of thing that I was like, everyone's talking about women. What in the world are they saying about women all the time? This is mostly what they were saying about women. But this is a lot of what they were saying. And so I compared this to what was being said about men. If the word sacrificed was said in articles about Hillary Clinton, it was almost 150 times more likely it was being said about or near the word men than anywhere else. So sacrifice, unarmed. Again, not great words, maybe not as offensive. And here we see like a mix. We see also interesting people's names get thrown in here if they were said a lot, or if someone said a quote at a Trump rally, and that quote was said in every newspaper across the country that day, that gets thrown in there as well. So we get like random places. Rutgers, I think, was on there, or will be. And you get some names and stuff. Questions about this? Yeah.
Actually, this might be a whole nother layer to add into it, but is there any way to catalog whether an article is written by a man or a woman, or whether there's an editor that's a man or a woman?
There's not. All of the newspaper articles were given to me without that sort of
or whether it was something
information.
AP versus... Yeah.
Unfortunately, no.
Yeah, okay. I was just curious.
It's a great question. Yeah. Other questions? Cool. So we'll just keep looking at some more words here. Near the word woman, we get nominated, and woman card was probably said a lot. The color pink comes out of nowhere, which is frustrating. I found that to be frustrating. No other colors were ever said. And these words are just really, I would say, problematic and frustrating, but go along with a lot of the discourse at that time. And a lot of these are quotes. A lot of these are quotes that someone said, and it doesn't matter who said them. If it was in an article about Hillary Clinton or in an article about Donald Trump, it's in there. So there are quotes as well. So these are near woman, and then these are words near man. Like universally less problematic, less the feeling, but kind of help paint a picture for what was being said, big picture what was being said around different gender marking terms. Other questions about this? Yeah.
I see that like your x-axis is in fractions, so I was wondering if there was like a way that lack of coverage could be quantified, because like going back to like your first slide with like Michael Phelps and like that tiny article about the woman world record setter.
Mm-hmm.
I mean, I feel like if for gender bias it may be the case that like these women-related accomplishments could not be like reported at all. So do you think like frequency or like lack of coverage could be quantified?
That's a great question. I'm going to think about ways that we could do that.
But were the number of data sets like similar, like the total number of articles in each category?
It was like roughly 20,000 and 30,000, but they're normalized. So it's you can compare apples to apples here. And the thing about this fraction, this is like that ratio where it's like 170 times more likely that fate was said near man than anywhere else. A normal word like a or the or would be a ratio or a fraction of about 1. It's equally as likely to be said around man than anywhere else. And so these are like really, really big outliers, and these are just the top 8. There are a lot of words that are said more around man than anywhere else, but these are just the top 8. And many words, I think, maybe getting to your point, have a fraction of less than 1, meaning that they were less likely to be said near man than anywhere else, so they were said in other places more frequently, which I think could help get at that question that you had. Other questions? We can keep asking questions later too. Great. So I looked at all of these, and it's really easy. when you're looking at this to make sentences in your own head, like, oh yeah, you know, this person probably said something like, you know, any of these things. You could say, I cherish women, or women are pigs. You can like imagine that at some point in time someone said something like that, and it's really dangerous to make it into a sentence like that without knowing if that's actually what was being said. And so while looking at this is, it's kind of like the poke and prod. You can get something out of it, but it's really dangerous to take that next step and say, this is what was being said, blah, 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 whatever. And so I wanted to get at a way of figuring out what was actually being said, a little more narrower of a scope. So I looked at 3-gram word trees. So every time the word woman was said, I looked at the 2 words before it and then the 2 words after it, and tried to figure out the most popular or most common ways to get to woman or man, and then the most popular ways after saying that to complete that sentence. And this is what I have for articles about Clinton, before the word women and after the word women. The font is small, I'm sorry. But interestingly, I guess the things I would notice are Hillary Clinton is, you know, advocating for women, pay for women, a lot of men and women being the most popular one. Men and women makes up 3.4% of all times women was said. So about 3% of all times women was said, it was men and women. Compared to women and men, making up only 1%. So I mean, I think that men and women is a default setting for a lot of people, so that makes sense. But it's significantly worse than articles about Trump, which we'll see next. But nothing really crazy. A lot of kind of skepticism about, ooh, like how's she going to do with women? What percent of women or number of women, that sort of thing. Like kind of political talk, you see. Reading off from women to the other side doesn't really give you much of substance, but looking at the words before women, I think does. And then you look at articles about Trump and the words that come before women. Men and women now makes up 5% of all times women is said. And you see a lot of his comments about women, his remarks about women, his problem with women, his relationship with women, his treatment of women, his support among women, that sort of stuff. So a lot of talk about his relationship with women, generally. Which is interesting because when I initially saw everyone's talking about women, I thought maybe people are guessing like, who are the minority women going to vote for? Who are the single women or college-educated women? That sort of thing. And I didn't think it would be as much about just commentary on his relationship with women. That sort of thing. You get also the women of Iowa have a strong stand here, which is just kind of funny. But I think there was probably some sort of big rally. But in both corpuses, you see a little bit of this bias. It's not just normal political talk when you're talking about women. I think universally you could say this isn't just normal political talk. We're talking here a lot about his relationship with women, and even in articles about Clinton was more normal political talk. When you look at this for men, you see straight political talk. Nothing exciting. I didn't even include the percents because they were all like the same and like pretty boring. Like just normal political talk. You don't get any sort of like meat from these 3 grams at all. These are in articles about Clinton, and then in articles about Trump, you get like for both men, of both men, as both men, of white men. Just kind of sentences are happening, which reflects, I think, general or normal political discussion. Questions about the 3 grams? I think this was a good way for me to see what was actually being said because it's so easy to make sentences in your own head, seeing all of those like really wild words before. And I guess, well, I'll talk briefly about this last thing because I have a little bit of time. Those were my poke and prod methods, a lot of like, ooh, what about this? What about this? I'm curious about this. But to get the big picture, you need a little more mathematical power behind you, but it's really not anything hard. And if you've taken my class, this is an example that I've used a lot in all of my classes because it's just vectors. And it's a lot of vectors put together. So I wanted to do topic modeling, which is a mathematical approach that you can make to figure out the total correlation between words within the same topic. So I wanted to know in all of these articles, all of the articles about Donald Trump or all of the articles about Hillary Clinton, what are the topics? Like, what are the big things that are being talked about here? Like, there's probably talk about the Middle East. There's probably talk about the southern border. There's probably talk about the other people that they're running against, that sort of stuff. And I just wanted to get at that and see the topics being discussed for each candidate and see if they were different in any way. And so to do this, I used just this topic modeling, which is a measure of mutual information. Basically, how dependent on each other are two different words. So, like, basic example, like roof and dog would be put together because they're probably used together, and like meow and cat would be put together. And it seems like magically the computer would know that those are two different topics. You're not saying meow dog ever, really, right? So the way it worked is that I built a matrix, a huge matrix, 20,000 words wide by 29,000 articles long. And it was just a binary, like a 1 or a 0. These are the 20,000 most popular words that were said in, I think this is articles about Trump for this matrix. And this is like word number 1. Was this word in this article? No. Was this word in this article? Yes. No. Yes. No. Yes. And I built it to go through every single article and do a 1 if the word was there and a 0 if the word wasn't, for every single article, for every single word. And this is, which I've alluded to in my classes, the code where I wrote it the first time. And I was like, oh, this is awesome. It works. And it says it will take 83 days to run the code for 20,000 words for 29,000 articles. And I was like, oh, man, this is due in 2 days. Okay, that's not going to work. And then, you just change a for loop and an if statement, and you nest them, and it took 3 minutes. And so it was like,
That for loop.
yeah, that for loop will really do it. It's crazy how much just small changes in your code can make it so much more efficient. And so eventually I was able to make this matrix, and I was able to put it into this CoreX, which is the topic modeling software I use that actually my friend helped develop. So it was a great little example for him to show how it worked. And these are the articles, or these are the topics that I was kind of given back. I literally put in 0s and 1s, and it gave me back topic 1, primary, party, win, cruise, delegates, covers, TED, nomination, Republicans vote. These are the 10 words that have the highest mutual information, and these words are all said, or most of the time these words are said together in the same articles all the time. I skipped a bunch of topics that were that were just less exciting. The money sign actually shows up as a word in the topic about taxes, money, millions, jobs, economic, company, billions, peg. Really, really cool. So with just giving it 0s and 1s, it was able to extract information about what words are said together most frequently. And this topic being first, the topics are ordered as like, this is the topic that is most talked about in all of these articles. In these almost 30,000 articles, this is what was mostly being talked about, which makes sense if you look at the time frame, the July to the August before the election, because that was primary season. You get, like you would think, a topic about Islamic, Muslims, world, foreign terrorism, that sort of stuff. A whole topic with just everyone's name that he was running against, basically, in the primary. The types of topics that you would expect. Down here, the 25th topic, meaning least mutual information, so least reliant on each other to exist, is a topic about the Democratic primary. Clinton, Hillary, Bernie, Sanders, Democratic, that sort of stuff. So meaning that you can really understand, big picture, what these articles were about. A lot of articles were about this, some were about economics, some were about all of these different things. But big picture, this tells you a ton about what was being talked about. And if you look at this for Hillary Clinton, you get the exact same picture. Well, you get what was happening, but it's very different what was being talked about. The topic with the highest mutual information was the server department, classified information, private investigation, FBI, emails, secretary, right? Which if you read any articles during that time, you know this was a big talking point. But really that it is the topic with the most mutual information is kind of shocking because that has nothing to do with, or should have nothing to do with her running for the Democratic primary or the presidential election. And then down here we get almost the same topic here that we saw about things happening in the Middle East. So still talk about that. There's talk about economics. There's talk about the Republican primary. And then there's a whole topic about Donald Trump, basically. And Donald Trump articles didn't have a whole topic about Hillary. Yeah, I think that's all the interesting things there. So it's a really incredible tool where you just give it some numbers and it can tell you these things are talked about together, these things are talked about together. And you could ask for 100 topics, I asked for 25, just like, what are these articles generally about? If you ask for too many, you get really weirdly specific and that's totally unnecessary. For the size corpus that I had, this seemed like a reasonable number of topics to ask for. Questions?
For topic 10, is that an open parenthesis?
It is an open parenthesis.
But is there no closed parenthesis?
Look, there's an open parenthesis here too, in almost like very similar words. It took out most of the, like, all of the periods and apostrophes and stuff, but it missed a few.
Okay.
Yeah, so it's kind of funny. I'm not sure, I mean, I didn't look at the data once it was cleaned. I kind of threw it in there with a ton of, it was very messy, and then cleaned it before doing stuff, but yeah, no closed parenthesis.
The letter U shows up.
Yeah, the letter U
on the
on
same
the other
line.
one, right? Oh, this
same
one
line
here.
both times.
Yeah, which is very interesting, and I think it has to do with Unicode, if anyone knows Unicode, like the way that computers take in information as text. I think it has to do with that and not being stripped from the same articles. Or like the same articles were problematic when it was cleaning the data. Yeah, some kind of funny things happen. But big picture, this like, if you could read 100,000 newspaper articles about the election and remember all of them, like this is probably what you saw or what you would have seen. And so I guess to just wrap up, I did all of this a couple of years ago, and I think about it all the time because it's stuff that's really exciting to me and stuff that I'm still working on, asking it more questions and finding new data sets to do this stuff with, which I'll talk about in a second. But I just still struggle with like, so what? Like I can carry this around and I can give talks to people when people want to know about it, but I still don't know what we could do with that as like as people, other than feel really burdened by it and really frustrated by it. And if we can do something, then that's great, and we can, I don't know, spread the word and notice it more. But that's a thing that I'm always kind of constantly wrestling with. Like, now what? You know, that sort of thing. And then also, in what ways can we apply this to our lives in terms of like, this is a really, I think this is a really cool approach for understanding words using like a tool that I have. Like I like math a lot, and so I can understand math and do math stuff and figure out some things about the world, which I think is really cool. But in what ways can that be useful to other people too? And so I just wanted to talk briefly about some other research that I've done in the hopes that maybe this will spark interest for you. And then if you need my help with any data stuff, I would love to. So I've looked in this data set at words used around not only gender marking terms, but race marking terms, or religions, or also ideas of community and culture and discourse and participation and what people are talking about in communities during this time, because I know that's not really the general scope of these articles. That's a work in progress. I've applied similar concepts to the Russian election ads on Facebook. So Russia like posted a bunch of Facebook ads, and they were in like broken English, and Facebook released that data set last winter, so I immediately grabbed it and tried to play around and see what was being said in those ads to just kind of see what was there. You can't read every single one. So I just wanted to see what was happening. Over the summer, I worked with Nicole and Seth and Rosalind and Charlie from Cultures of Dignity to look at the SLS survey results that we took last year. And so that we have talked a lot about what the results were, because a lot of them were like text box, right? As students would know that you filled out a text box on like a 25-page long survey that took like 45 minutes. Instead of just clicking, it's easy to do statistical tests on things where it's like, rank this on a scale of 1 to 10, rank this on a scale of 1 to 10. But when we give you a text box, it gives you a lot more freedom, but it makes it a lot harder for us to understand what people are saying. So I was looking at the text results from that over the summer and talking to Nicole about how we can shape SLS in a productive way based on what the students are saying. I also was just granted access to the NMH teacher comments from last year. All comments that teachers wrote about students, and I'm curious if there are different ways that we talk about male students versus female students, or students of color versus white students. And so I was given that data 2 days ago by Jay, and so that's coming soon. And I think that's like one way that we, as a group of people, can just actually like maybe make some changes or learn what we're actually doing. Maybe just like hold a mirror up to ourselves and say, like, this is what I'm intending, is that what's being perceived as well? So that's coming soon. And I worked with my friend on his master's thesis at Dartmouth, which was about performative masculinity around the hashtag Saturdays are for the boys. Do we know that? Yeah. Saturdays are for the boys is a hashtag on Twitter that's really popular, made popular by Barstool. Yes, Barstool, of course. And to help him with that, he's doing his master's thesis on performative masculinity. And so I have access to a random sample of 10% of all tweets from my grad program. And so I gathered every tweet. Well, I helped gather every tweet that used hashtag Saturdays are for the boys, or the abbreviation SAFTB, which is a popular abbreviation for that, and use similar sort of language analysis to understand what people are saying in terms of performative masculinity around that hashtag, just to kind of see what people were saying. And so that was, I could code up some things and then give it to him, and he can write his thesis on that. But if any of these are exciting to you, or you have a project that you're excited about, I'd be excited to work with you too. Do you have any questions? That's all I have. Any questions? Great.
So related to this last slide, if you had access to any related data set and a year to work on it, what would you be most excited to focus on?
That's a great question. I've never thought of that because I've never had so much freedom. I don't know. There's so much that you can ask, but instead of the asking specific questions, the big picture, applying more big picture, tell me what's happening in this data set types of applications, like the correlation, explanation, topic modeling, would help paint a better picture of all of this. But all of these are kind of in the same vein of the things that I'm interested in and excited about. That's a hard question.
Sorry.
That's okay. Others?
So there's a group of students who are working with Sarah, and to a lesser extent me, the Youth Participation Action Research Group that did the political discourse thing last year. And I think they're zooming in on questions about how people experience class difference at the school, how they understand it, and we haven't sort of figured out how to pursue that question. But I'm now thinking that having people fill in text boxes and then having a smarter way to look at that than simply reading through it and going, well, I don't know, this is what I think.
Yeah, right? You can keep tally marks all day long of what people are saying, but
yeah.
That would be really.
You're making it sound easy, but it doesn't sound easy to me.
We could do it
We'll be
together.
talking.
We could team up. Yeah, other questions?
This applies to both this specific political newspaper articles, but also anything using this kind of software, this kind of program. What makes you kind of the most hesitant to present this, what do you think are the biggest kind of holes that can come from this kind of statistical research?
I can think of two things. Big picture, like I mentioned, it's really easy to jump to conclusions when you see these like hot button issues and big, mean words. And so I worry and I'm a little hesitant that an audience would not really understand how dangerous it is to jump to those conclusions. And I worry that I would present it in a way that was not explaining how dangerous that really is. The second is that words are really hard to deal with because they have so many meanings. So for example, in my research group from grad school, they do a lot of happiness rating, so understanding the happiness of any data set. So I could apply my happiness stuff to this. Are articles about Hillary Clinton happier or sadder than articles about Donald Trump? Or the words around women compared to the words around men? Or anything. You can look at punk rock lyrics. And are those happier than country music lyrics, for example? So this is all research that my advisors in grad school have done. And happiness is really hard when you look at articles like this and you see emails. Emails are pretty happy, but in the context of Hillary Clinton, it doesn't mean just emails, right? Or the word bill is just a normal word that probably means money, except when you're talking about Hillary Clinton's husband, and it doesn't differentiate the two. And so there's a lot of places where things can go in a different direction than you thought because you're using different versions of the same word. Does that make sense? So yeah, working with words is really hard, which is I think why it's so exciting and very challenging.
If you use like that same algorithm on like just all journal types of articles, I guess, do you think we could see whether or not journalism as a whole is gender biased or like specific like political commentaries?
Yeah, I think that that's like the next step for this is to say, okay, looking at this, these are words that are said more often around women than anywhere else in these articles, but is this a consistent trend throughout? Like frequently you could imagine that some of these words would be said about women and not about men as much. So where is the benchmark for like, maybe the ratio is 35 for normal articles, and so we could just compare how different it is. And I think that would be the next step to making this. There's no such thing as like, this is a non-biased article. Like this is the gold standard or something. There's no comparison for that because for so many reasons. And so getting to that place would be the next step. Other questions?
Okay, so I'm a part of the social entrepreneurship class, and something that I've been working on as I've started developing my own enterprise is about measuring feedback, and a lot of that has to do with quantifying stuff. And one of the things that I've been really aware of is that a lot of the feedback that I'm getting and trying to get is very intentional by me. So like I have very definite intentions about what I'm trying to get out of this feedback. So have you had that issue with like being very aware of how that might skew results and how you can get a complete picture but also get what you want out of it?
Yeah, I think in this project that's why I took so many approaches, because I was afraid that I was just gonna, if you don't look for something, you're not gonna find it. And so looking at the poke and prod, but also just kind of big picture, tell me what's here, sort of stuff gets at both sides of that. When Seth and I talked to Nicole over the summer about this data set, we mentioned that if we had been part of the survey building team, we could have been able to make more conclusions about the results because of the way that some questions were asked. Yeah. So if you're just on one end of it, you kind of inherit the biases that were asked when you were not part of it. Does that make sense? Any other questions? Thank you so much for coming.
What I wish is that we shared our last year.
Faculty, how do you do?